Hello, Mishler Math, back again. We're going to identify and evaluate rational functions today, and we're going to graph rational function and find the domain, asymptotes, and the wholes. What does all that mean? Well, rational expression. Remember, the word rational in math, ratio is the root word. So a rational expression, okay, is basically it's a ratio like P over Q, where P and Q are polynomials. That's what a rational expression is. P over Q, like a ratio. It's P over Q where P and Q are polynomials. And a rational function, of course, is when we make that into a function. We say R of X, for example, equals P over Q. Okay? So that's pretty simple. The first thing we want to do is find out the domain. What is the domain of this function? Okay? And I pointed to the Q because the Q determines what the domain is. The polynomial on the bottom determines what the domain of the function is going to be. For example, remember when I said f of x equals 1 over x. Now, if I graphed that, remember what I had. I had something like this, okay, and like this, only neater. And it goes like that. Anyway, so as you can see, the curve, as you get higher, as x gets higher and higher and higher. For example, let's suppose you have x equals 1,000,000. Well, then y, or f of x, is going to equal 1 over 1,000,000. So it's a very, very, very tiny number, but it's not quite 0. So the horizontal x-axis is your horizontal asymptote. Your vertical y-axis is your vertical asymptote. And of course, x is, or the function is undefined at 0. You cannot have 1 over 0. You can't have anything over 0. Division by 0 is undefined. So that's why we say we have a vertical asymptote. In this case, it's the y-axis. Well, in order to find a vertical asymptote for something like f of x equals x squared minus 7x plus 12 over x squared plus 9x plus 20. How do I find the domain? Okay, for example, in this one, the domain is all real numbers except x equals 0. So the domain, remember, the domain is all possible values for x. So here, x cannot be anything that makes x squared plus 9x plus 20 equal to 0. So let's just solve this polynomial, or this quadratic equation here, to find out what our domain is. Well, let's see, x plus 4 and x plus 5, this thing factors very nicely. So that means x plus 4 equals 0, x plus 5 equals 0. Subtract 4, x is negative 4, x is negative 5. Subtract 5 from each side here. So what we say here is that our domain for this particular rational function is all real numbers except, this is the most important word here, except x equals negative 4 or x equals negative 5. We also might say the domain is all real numbers. This is a symbol for all real numbers. X does not equal negative 4, negative 5. That's an abbreviated way of writing that. It'd be faster and easier to write it that way. The point is, you need to know that the domain is any real number except what makes the denominator into a 0. That's the most important thing to remember from this. So let's try something else here. We've got asymptotes. Now, if you remember an asymptote, That's something that the graph curves and it kind of gets closer and closer and closer. It never quite touches it. Okay? Now, the f of x equals 1 over x, like we said, it has horizontal and vertical asymptotes. Okay? So we're going to find we got a blue rule here. And I call it that because, as you know, in the textbook, it's in a blue box, okay? A vertical asymptote. Vertical, obviously, means up and down. Vertical. Vertical asymptote goes like this. If x minus a is a factor of the denominator but not the numerator, then x equals a. Notice this is the form as x minus a. So x equals a is a vertical asymptote. Okay, and sometimes I go VA for vertical asymptote, HA for horizontal asymptote. Anyway, let's look at an example. Suppose g of x equals 2x over x squared minus 1. Okay? X squared minus 1. So that means that 2 of x over, remember you can factor this into the two conjugates, x plus 1 and x minus 1. And so neither one of these is a factor of the numerator. Notice neither one of these is repeated in the numerator. So if x minus a is a factor of the denominator but not the numerator, then x equals a is a vertical asymptote. And so if you look at this, x plus 1, I'm sorry, let me rewrite that so I don't confuse you. X plus 1 is x minus a. Okay, so a equals negative 1. X minus 1 is x minus a. So bottom line is we have two vertical asymptotes. We have vertical asymptotes at x equals 1, x equals negative 1. And I'm going to take a moment and graph this, and we'll see what we're talking about here. Okay, we have 2x over parentheses x squared minus 1. And believe me, it's so much easier if you, or better, if you graph the original form. Not like, don't do this one. If you made a mistake when you factored, you're going to get a wrong graph. So let's look at the graph. And you see it kind of looks like there's a vertical line there. But if you look at it more closely, you would find that actually this thing goes down here. And if I change the mode on that, I can get it to where it doesn't show up that squiggly line here. But basically what we have is a graph that looks like this, okay? We have a vertical asymptote at x equals negative 1, a vertical asymptote at x equals positive 1, and my graph, if you look at this, okay, it's got a take another look at that again, make sure okay, there we go. So we've got this thing goes like this and goes like that. This thing goes like this, goes like that, and this one goes like this and crosses over here and then goes like that. So that's what our graph looks like. We got these two vertical asymptotes that the graph kind of keeps getting closer and closer to, but it doesn't quite touch. So, getting on from there, what do we have? We have the next page, which I'm going to find here in a second. Okay, what about horizontal asymptotes? Okay, so let's say the horizontal asymptote. Well, this is a little bit more complicated, okay? And this one, your blue rule says if x minus a is a factor of the denominator but not the numerator, then x equals a is a vertical asymptote. Well, for the horizontal asymptote, the rule is a little bit more complicated, okay? And so, let's say again, r of x equals p over q, okay? This is my rational function. So there are three different possibilities, okay? We're looking at the degree of r, or p, and degree of q, okay? So I might abbreviate that degree p and degree q. So for A, if the degree of p is less than the degree of q, that means that y equals 0 is my HA, horizontal asymptote. Ha! The other possibility, the degree of p equals the degree of q, well, that means that y equals a over b is horizontal asymptote. Well, what's a over b? These are the lead coefficients. A and b are lead coefficients. And you remember from the last section what a lead coefficient is. Okay, are lead coefficients of p and q in that order. A is a lead coefficient of p, q, or b is a lead coefficient of q. And we're going to do an example, so hold on there. And then C, degree of p is less than, wait, I say less than? Oh, no. Greater than the degree of q. That means there is no horizontal asymptote. Okay? Now, these are in your book, so don't worry about that. If you didn't get this written down or anything, just check in your book and you'll be fine. It's a blue rule. There's another blue rule written in your book. I just tried to abbreviate it a little bit, make it a little more sense. Hopefully it makes sense to you. So, let's show an example of how we're going to find asymptotes. Okay? Suppose I have r of x equals x over x squared minus 2x minus 3. Well, you're probably going to get used to this real quick. First thing you want to do is factor it and find out what your factors are. So x minus 3 and x plus 1 are your factors. Now, your vertical, what we're trying to do is we're trying to find the asymptotes, okay? So the vertical asymptote, remember your vertical asymptote, you look at the factors of the denominator and see if they're also repeated in the numerator. Well, neither one of these factors is repeated in the numerator. So you say that we have vertical asymptotes at x equals 3 and x equals negative 1. Remember, you make x minus 3 equal to 0. Okay, so you add 3, x equals 3. Okay, so please don't get mixed up with these signs. Pay very close attention to those signs. The next thing is your horizontal asymptote. Okay, the degree of p, you look at this as p and this is q. The degree of p is less than the degree of q. Okay, so what that means from our blue rule that we had, that means that the horizontal asymptote is at y equals 0. So we can actually use this information to graph this, except I know how to make straight lines and I just forget to use that. So there's our vertical. All right, so I've got a vertical asymptote at x equals 3. 1, 2, 3. Okay. And this, I can't do a straight line that's dotted, so excuse me, I'm sorry about that. And I got a vertical asymptote at x equals negative 1. Okay? And I've got a horizontal asymptote at x equals 0, which is my, or y equals 0, which of course is my x-axis. Okay? And so let's take a look at what that graph looks like. And again, we go here and we say x over x squared minus 2x minus 3. And graph that thing. And sure enough, there's my vertical asymptote at x equals -1. There's my vertical asymptote at x equals 3. And this looks a lot like that graph we talked about a little while ago, where we've got this thing going like this. Okay, this curve goes like this. This curve comes in here like this. Notice your horizontal asymptote is your x-axis. And then you've got this thing here going on. And you might look at that and you say, well, wait a minute, that's crossing the asymptote. Yes, you do have a value there for that. We'll talk about that later, but don't worry about that for right now. Just look at what's happening on here and here, okay? That's what your asymptote is all about. And there's one more thing we have to talk about, and that is holes in the graph, okay? And let's, this is a very, very common occurrence. You get something like this. F of x equals x squared minus 9 over x minus 3. Now, let me graph that right away, and let's take a look at that, okay? And, okay, clear. X squared minus 9, x squared minus 9 over x minus 3, x minus 3. Now, we can assume, of course, that we're going to get some kind of a curve like we've seen before, but look at this. What in the world is going on there? How did we get a straight line from this thing? Well, let's factor this. X plus 3, x minus 3 over x minus 3, and that equals x plus 3. So what you have is a graph of x plus 3, except for one thing. There's a little doodad going on here, okay? And that is, if we look at the trace, we trace this thing, we got x equals 0, x equals -2, okay, x equals 2, okay, x equals 3, enter. Wait a minute, look here. There's no y value for x equals 3. And sure enough, if I look at the table, and I get down here to x equals 3, and it says error. Well, why is that? Well, look at this. What happens when x equals 3? That makes your denominator equal to 0. Division by 0 is undefined. So this is what we call a hole in the graph. This happens a lot, okay? A hole in the graph. When x, okay, a hole in the graph occurs when x minus b is a factor of numerator and denominator. Okay? And then a hole at x equals b. So you notice x minus 3 is a factor of the numerator and the denominator. So there's a hole at x equals 3. All right, one more example and then we'll be wrapping up here. And we've got, let's suppose y equals 3 minus 2x minus x squared over x squared plus x minus 2. So we want to find all the asymptotes and all the holes in the graph. So the first thing I'm going to do is factor top and bottom. I'm going to rearrange this and put this in standard form. And I'm going to pull out a negative sign. I got negative x squared, so let's make it negative x squared plus 2x minus 3. Negative 3 is a positive 3, which is what we have here. All right. And then over here I've got x minus 1, x plus 2. And so that equals a negative x plus 3, x minus 1 over x minus 1 and x plus 2. Now, right away you notice that I've got this and this, so there's a hole at x equals 1, because x minus 1 is a factor of the numerator and the denominator. Okay? The next thing, if I look at x plus 2 is a factor of the denominator, but not a factor of the numerator. That means I've got a vertical asymptote at x equals negative 2. Remember, I've got the form is x minus a. So it's negative 2. Okay? And finally, the degree of p is equal to the degree of q. Okay? So I've got to use the horizontal asymptote rule, which says that the lead coefficient, now if I put this p in standard form, this is going to be my lead term, and the coefficient there is negative 1. So horizontal asymptote at negative 1 over 1, which equals negative 1. Okay? So I've got a horizontal asymptote at y equals negative 1. Okay? Your practice problems are on page 495, 6, 8, and 10. Your homework is page 495, 12 through 40 even. Okay? Practice problems you hand in at the end of the class on your warm-up and notes. Thank you very much. Have a nice day.